work better. I'm making the slides better for a video presentation, okay? All right, so let's get started. Today is, well, this is where we left off. Elbow. What I have here are 3 articulations that make up the elbow joint. 1, 2, 3. So let's kind of take note of what I want you to know for these 3 articulations. So, number 1, that is an articulation between the radius bone and the humerus bone up here. And specifically, what you need to know is that the radius, this is the head of the radius that is articulating with the capitulum of the humerus. So it's the head of radius articulating with, write that in neater, capitulum of the humerus. Okay, so that's the specific articulation for that. What you can notice is that the head of the radius is kind of concave, and that kind of like fits nicely with the ball shape of the capitulum. So the head of radius on top is concave on top, where the capitulum is more like a ball shape. So the ball fits in the concave shape, is all I'm really trying to say. Then I have this picture here. The radius bone radiates during pronation and supination. The ulna stays still. So when the radius radiates, it kind of crisscrosses with the ulna bone. That's worth noting. Radius radiates. All right, the second articulation, number 2, is an articulation between the ulna and the humerus. So let's figure out what's going on there. This articulation of the elbow between ulna, humerus. The ulna is like a monkey wrench bone, and if you look right here from a lateral view, that part of the ulna is called the ulnar notch, and that is articulating with the trochlea of humerus. So ulnar notch articulates with trochlea of humerus. Okay, so that's the main articulation there. That's pretty much the main articulation of the elbow joint, and basically this is what makes the elbow a hinge joint for the movement allowed flexion and extension. Okay, let's move on. The third elbow articulation is between the radius and the ulna, and we just call it the proximal radial ulnar joint, as the slide says. So really, it's the head of radius that fits in the radial notch of the ulna. So let's write that down. So for the proximal radial ulnar joint, for the radius, and then for the ulna, the ulna has a notch for the radial head, so it's called the radial notch of the ulna. And it's the radial head that fits in the notch. So this is the proximal radial ulnar joint. That is what allows the head, which is like the knob end of a baseball bat, it just kind of spins in that joint as the bones crisscross during pronation, supination. So those are the three joints of the elbow joint I think you should know. From this slide, I point out a couple of structures on the humerus. The coronoid fossa, a little space right there, and then the olecranon fossa, which is a much bigger space on the posterior aspect of the humerus. So, I made this slide because I want you to know that these fossa receive the processes of the same name. So during elbow flexion, when the elbow is fully flexed like this, the coronoid process fits in the coronoid fossa in elbow flexion. So elbow flexed, coronoid process of the ulna fits in the coronoid fossa of the humerus. Once again, coronoid process fits coronoid fossa. And the same thing for the elbow when it's fully extended. The olecranon fits in the olecranon fossa. So let's simply write that down. That's when the elbow is extended. So elbow extended. Olecranon of the ulna fits in the olecranon fossa of humerus. All right, some questions for you. What I said in class was I'd kind of give a study guide for each of these lectures to make sure you're getting what you need to get out of it. So think of this questions for you within the PowerPoint as the study guide. And when I make up a quiz for this lecture, I'll kind of use most of these questions for you as the basis for the quiz. So if you can answer them, I think you'll be in good shape for that quiz. And I'll just kind of pause now. Of course, you can hit the pause button because you're watching this on YouTube. But I'll come back and I'll answer it verbally just to make sure you have confidence that you're getting what you need to get when you try to answer these on your own. Be back in a second. All right, number one, elbow. Name the specific feature that forms each articulation for A, humerus ulnar articulation, what we had said was for A, the head of, the trochlea of the humerus fits in the trochlear notch of the ulna. For B, it is the capitulum of the humerus that fits the radial head. For C, that proximal radial ulnar joint, the head of radius fits in the radial notch of the ulna. The movements at the elbow, pronation, supination. Remember, the radius radiates, ulna stays stationary. Flexion, extension. The elbow is a hinge joint because of the trochlea fitting in the trochlear notch. All right, let's move on. Let's talk about the surface features, and we kind of did already, but just to be clear, here's a picture of radius and ulna. Radius, ulna. They're parallel bones of the forearm. If we look at the ulna first, I have 1, 2, 3. So what are those? Surface features of the ulna, number 1. That is the radial notch of the ulna. The radial notch of the ulna, it fits radial head for that proximal radial ulnar joint. Number 2, they're trying to point to the trochlear notch. Which again receives or fits the trochlea of the humerus. So that makes sense. The radial notch fits radial head, trochlear notch fits trochlea. Number 3, that is the coronoid process of the ulna. And what we had said is that fits in the coronoid fossa of the humerus when the elbow is flexed. Next slide. So number 1, radial notch. I just wanted to give you another image of that radial notch. The radial notch of the ulna. It receives that round knob end of a baseball bat radial head. Number 2, I tried to make a curved red line to kind of approximate what that trochlear notch really looks like fitting the trochlea. You can see it better from a lateral view. And number 3, just imagine that when you flex, that this process fits in that fossa. Okay? Moving on. All right, here's the ulna. It's a posterior view. I'm going to clear the board. Just be able to recognize the olecranon. Like when you elbow somebody, you're elbowing them with the bony part of your ulna, pretty much the olecranon. So I'll just describe it as the bony proximal part of the ulna. Bony posterior ulna. Moving on. Sometimes it's called the olecranon process or just olecranon, either is fine. All right, so that was the proximal end. Now this is the distal end. That is that. So note that the ulnar head is distal, and that's a bit unusual for bones. Usually heads are proximal and then something else is distal. For bones, usually condyles are distal and heads are proximal, but not for the ulna. For the ulna, you had that notch in the olecranon, and distally, the bone goes a little bit more slender, and at the bottom, you have the head. So just note that the ulnar head is distal. The other process, sticking down, right there, styloid process. Styloid means like a stylus, like a pen. It's a little pointy tip, like a pen tip. They call it the styloid process, also distal. So put the styloid process of ulna is distal. Here are some surface features for the radius bone I want you to know. Number one, that is the styloid process of the radius. So both radius and ulna have a styloid process. Number two, it's hard to see from the front. This is an anterior view of this bone. But if you had your eyeball right there, what you would see was there's a ulnar notch of the radius. So that's what number two is. Ulnar notch of the radius. It fits, it receives the ulnar head. And that forms the distal radial ulnar joint, which also moves during pronation supination. Distal radial ulnar joint. All right, so for number one, number two, here's a closer up view of the distal end of this bone. There's the styloid process, and right there where they touch, that is the distal radial ulnar joint. So you see the ulnar head fitting right in that notch. So let's go back and do 3 and 4. 1 and 2 are the distal end of the bone. 3 and 4 are surface features proximally you should be able to identify. Number 3 is the radial head. What you should see about that is the radial head, see the top of it fits the capitulum, but then the cylindrical knobby part of it fits with the ulna. So this head articulates with both of those things. Fits both capitulum and radial notch. The capitulum, that's one of the humoral, one of the condyles of the humerus. Remember the radial notch, that's of the ulna. Number 4, radial tuberosity. Right there, that roughened portion, right there. Radial tuberosity, that's where the biceps brachii inserts. That's one of the places. biceps brachii. All right, more questions for you. I'm going to take a minute here, get a drink of water. You kind of look over those, and I'll come back and I will answer them. Okay. Name the specific feature that forms each articulation for proximal radial ulnar joint. What forms that joint? Well, head of radius fits in radial notch of ulna. Distal radial ulnar joint. Well, head of ulna fits in the ulnar notch of the radius. Movements allowed, pronation, supination. Which feature of the ulna is your posterior bony, let's just say bony elbow? Got cut off there. The answer is olecranon. Is the radial head proximal or distal? Proximal. Is the ulnar head proximal or distal? Distal. Where does biceps brachii insert? Boom, right there. The radial tuberosity. Which bone has the styloid process, the radius, ulna, or both? The answer is both. There's the styloid process of the radius, and there is the one of the ulna. Moving on. Bones of the wrist and hand, and I have a picture of a left and a right wrist. Let's remember that the carpal bones are the bones of the wrist. And you have 8 carpal bones, and think of them as 2 rows of 4. Yeah, let's use the right as an example. It goes, well, proximal then distal. So the proximal ones, pretend the radius and ulna are right there. I have the first letter of each. Scaphoid, lunate, triquetrum, pisiform. So I'll list them just like that, from this way to that way over here. Scaphoid, L, lunate, triquetrum, P is pisiform, shaped like a P. It's your proximal row of 4. The distal row of 4. Trapezium, trapezoid, capitate, hamate. trapezium, trapezoid, capitate, hamate. Study the palmar view. Oh, I'm sorry, that's a misspelling. But I usually use the right or the left, but, well, of course, right or left. What else is there? But I always test on the palmar view. Palmar view, not the dorsal view. Palm, bones right here, not this view. Although you could study that way. I just always use the palmar view. Moving on. There's a blank one for you to study. Scaphoid, lunate, triquetrum, pisiform, trapezium, trapezoid, capitate, hamate. Then the mirror view left, scaphoid, lunate, triquetrum, pisiform, trapezium, trapezoid, capitate, hamate. It just takes some time. Just rehearse, just be able to identify the bones within the wrist, just like these types of pictures, or say this one, they're right there. But let's move on and talk about the bones of your palm, the metacarpals. Metacarpals, bones of your palm, and they're numbered 1 to 5 as shown on the slide. Metacarpal 1 through 5. Just remember, metacarpal 1 articulates with the thumb or the pollex. So 1 pollex, then metacarpal 2 with digit 2, and so forth and so on. Metacarpal 5 articulates with digit 5. Metacarpal 5 articulates with digit 5. Okay, so just be able to identify the 5 metacarpals. That's pretty easy. As long as you remember, thumb is 1. Okay. Thumb is 1. All right, then let's get into the bones of the fingers or your digits. The bones of your fingers are the phalanges. Bones of digits are phalanges. You got 14 per hand. Let's just count them. 1, 2, 3 in this finger. 3, 6, 9, 12, 13, 14. So each finger has a proximal phalanx, okay? But only digits 2, 3, 4, 5 have a middle phalange right there. The thumb does not. The thumb only has proximal and distal. It's only got 2, the other's got 3. The distal phalanges, that bone tip right there, that's the last one. Okay, it's the most distals, the distal phalanges. You got 14 per hand. Just be able to identify them. Then the joints between your wrists and your fingers. I have the abbreviations on the slide, but let me spell them out for you. All right, CMC, that joint here between the distal row of the carpal bones and the metacarpals. So it's carpo-metacarpal joint, CMC. Carpo-metacarpal joint, the CMC. Then this joint here between the metacarpals and the proximal row of phalanges, that's the MCP, metacarpal phalangeal joint. Metacarpal phalangeal joint. I'm just going to call it what it is, MCP. Basically, that's your knuckles. Next joint, going from proximal to distal still, this joint right here is your DI. Oh, wait, ooh, there's a mistake on this slide. Hold on a second, let me correct the mistake. All right, got that straightened up. The next joint out, this proximal interphalangeal joint, and it's all right here. Huh. Correct. I was just looking at my mistake right there. Well, anyways, okay, this joint right here, the PIP, proximal interphalangeal joint. That's PIP for short. The DIP is the distal interphalangeal joint. The DIP. So for example, if I move my finger like this, what joint is that? That's the DIP, that's the PIP, and then that's the MCP there, your knuckles. Here's a blank figure you can study. All right, some more questions for you. I'll pause for a second and check back. All right, guys, number one, can you identify all 8 carpal bones? Again, just takes practice. Scaphoid, lunate, triquetrum, pisiform, trapezium, trapezoid, capitate, hamate. You could like Google mnemonics for those 8 carpal bones. There's a lot. Some are rated R. Does metacarpal 1 articulate with the pollex or digit 5? Remember, thumb is 1. Metacarpal 1 articulates with the pollex. How many phalanges are there? 14. 3, 6, 9, 12, 13, 14. What are your knuckles? That joint right there, that is the MCP, metacarpal phalangeal joint. Here are some more slides I have of bones I took of lab, and what I'll do is I'll go through the correct answers. And if you want to practice, go ahead. Hey, these may pop up on a quiz or lab practical or lecture exam, whatever. But they're here. Let's go over them since we're now done with the bones of the upper limb. So that is pointing to medial border. Right there, medial border. I always look at the glenoid, that's lateral, that's medial. This is the anterior aspect of the scapula, that picture. It's hard to see that process sticking out of the bird's beak. That is the coracoid process. And by the way, if you want to quiz yourself, run the video back, just turn the sound off and see how you do. That up there, acromion. That right there, that's a lateral view. That is also acromion. That is the glenoid. That is the scapular spine. Okay, so don't get confused. Scapular spine there, but then when it gets more lateral, that big process there is the acromion. Acromion, scapular spine. This is a posterior view that is pointing to this whole area here, inferior to the spine, infraspinous fossa. That's pointing to the acromion. Scapular spine. Here's the humerus, a couple of views there, proximal and distal. That is the medial epicondyle. That's pointing to the capitulum. That's pointing to the coronoid fossa. That's pointing to the trochlea. Intertubercular groove for that one. Lesser tubercle, also called tuberosity. The lesser one. Anatomical neck. So I kind of have some of the things labeled there for you. This one's kind of a gimme because I tell you that's medial. Medial epicondyle, that was not a trick question. In the posterior view, you can see the trochlea. Cannot see capitulum very well. Answer there, trochlea. That space, that fossa, olecranon fossa. Identify bones. Radius, ulna, humerus. I'm pointing to the radial notch of the left ulna there. Just kind of wanted to take a picture of it so you can get a view of it. And then so this next shot is the head of radius fitting in that little notch space, forming the proximal radial ulnar joint. Here's the distal end of the forearms, forearm bones, and there's the styloid process of each bone. Normally, the styloid process of the radius points a little more distal. Okay, something I may talk about later. If you fracture your wrist, these styloid processes usually break off, and in an X-ray, the radius bone, it kind of like, instead of being more distal, it kind of becomes more even on an X-ray when you fracture it. Fracture distal radius. The styloid processes become more even. When normally the styloid process of the radius is more distal. Well, this is the end of this first lecture. I hope everything works out. You can hear me okay, and you can see everything okay, and you have access to these slides. And get ready when you're done answering those questions for you and studying your lecture notes that you take the quiz associated with this lecture. And I'm going to have all my office hours on Confer Zoom. So I'll send an email of how you can kind of talk to me face to face in an office hour online. Of course, you can always email me, but if you want that kind of face-to-face, my computer, I see you on your computer and vice versa, look for a Confer Zoom announcement on how to use it. Okay? All right, guys. Thanks.